Good morning, good afternoon. Thank you for joining Qumulo's All-NVMe webinar today. Really appreciate you taking time out of your day to jump on. Joining us today is myself. I'm Molly Presley. I am responsible for global marketing here at Qumulo. And then our special guest today is Jason Sturgeon, who is one of our senior product managers focused in particular on delivering new platforms, new hardware technology, and our overall appliance approach at Qumulo. So Jason, thanks for joining us today.
I'm happy to be here.
All right, great. So we're going to take about 20 minutes of your time today to talk about developments in the file storage market and the platforms that are available to us to really run these really high performance file systems on the latest and greatest technology available coming out of the industry. So really what we're going to focus on is really a little bit about NVMe from a device perspective, from a technology perspective. What are the benefits and what do we see the predictions of adoption looking like in the market in the coming years for NVMe? And then really delving into what made it so hard. Why was it difficult to take advantage of these new NVMe devices when they came out and put them into complete systems and complete solutions? So we'll tie things up with what made it difficult, why now we actually have this technology in the market and it's accelerating workloads and you can buy it today, and what Qumulo is doing uniquely to bring it into our solutions. So from a little bit of primer background information, how did we get here? As we all know, we have this just continuous desire for more speed in technology. Businesses are so data-driven. We are creating data. We're wanting to get information out of that data. We're wanting to retain it, to go back and do analytics and look at it in the long term. And what has happened is with the shift in Moore's law and how processors are being generated, the types of bottlenecks are starting to shift around within a system. So data is being created very quickly. The processor roadmap has moved faster than the storage roadmap as far as how quickly it's been accelerating. And then, as we've been looking at the capacity of disk drives versus the capacities of SSDs, that was converging a few years ago, and now we see SSDs really skyrocketing in their capabilities to increase capacity very, very quickly. So this is a kind of a shift of where are we creating enough performance, where do we have enough capacity, and then how do we get enough performance to be able to utilize all the capabilities of those different devices. So with all these shifts, right now storage has become the bottleneck. We know there will be other bottlenecks in the future as we start to solve this storage performance bottleneck, but right here today what we want to talk about is how Qumulo has taken advantage of innovation in the industry standard hardware space, innovation in our file system to no longer be the bottleneck, and hopefully push that over, I think, to the network side is what we think will happen next. So Jason, do you want to go a little bit more deeply into this?
Yeah, so when we look at, there was this pressure to make storage faster, and hard drives were really a clear bottleneck, and as the technology that we use to make processors faster was applied to storage memory and the ability to have solid-state drives or SSDs, we were able to make that much faster than a hard drive. And so SSDs are clearly faster. No matter what kind of technology you're using to connect to that SSD, it is really a game changer in how much different that experience is. And so as those started to come out, we basically took old technologies that were designed for hard drives to get them into a form factor that could easily be consumed. And so what that translates to is we had technologies like SATA and SAS as ways to connect to hard drives, and we just used that same technology to adopt this new flash technology quickly. The downside to that is we created inherently huge bottlenecks. So when we go through a SATA controller, we're limited to 600 megabytes a second, and when we're going through a SAS controller, we're limited to a gig. And then there's this thing called a command queue. So basically, it's like how many instructions or how many requests can I get queued up in the system. And so again, based on hard drive technologies, which only had one lane or one ability to have one queue in there, we would have one queue with either 32 or 254 commands. And so the reality is flash can handle way, way more than that. The SSD technologies can do way, way faster than that. And so what we did is the industry decided we needed a new way to access this to unlock the full potential of it. And so what came to market was what we call NVMe, or non-volatile memory express. And it's a new way to connect to that same flash technology. So the reality is the flash technology or NAND chips that are manufactured, whether they be in your phone or your laptop, that's the same technology that can be behind a SATA controller as can be behind an NVMe drive. And so the cost to produce that is literally the same, but when you access it via NVMe, you're accessing it many, many times faster. So we get 8 lanes of connection, and we can support up to 6 gigabytes of bandwidth in that connection. And we can have these huge queues, so we can have 4 billion commands queued up. So we can really just hammer the device and take full advantage of it. And it's doing this over a connection that's referred to as PCIe or PCI Express, which is basically that slot that you plug your video card into. That's the kind of bandwidth we're talking about, that you're getting directly connected to the CPU. So you're removing that controller. There's nobody in the middle anymore to make that slow. You're basically connecting the CPU directly to the storage.
Okay, cool. So essentially, you know, I love the analogy of we're no longer cruising down a country road in our Ferrari with, you know, all this horsepower that we can't really take advantage of. We're out on the superhighway with our fast car, and we have the lanes and no speed limits kind of holding us back, as I guess a layman's analogy for what we're talking about.
I like that.
Yeah, so maybe we can talk just for a minute, Jason, on PCIe lanes and how you think about that within hardware. So there's some environments that early on put NVMe into a SAS or SATA-based controller system, and that creates different bottlenecks versus actually putting it into its native PCIe channels. Can you talk just a little bit about that?
Yeah, so just to correct you slightly there, so the SSD or the solid-state drive is the flash. Traditionally, we'd have it in a SATA or a SAS connection, and you're creating that middleman connection. And so the beauty of that is it's very simple. Like the same technology we've been using to deal with hard drives being removed from the system is just as it was before. So there wasn't really any technology software changes that had to be done to take advantage of that. But when we change the dynamic here by making it directly accessible via the PCIe lanes, it changes that interaction. It makes it way, way, way faster, but it also makes it more complicated to interact with, which I'll talk a little bit about later. But it really unchains the true performance potential of the SSDs.
Perfect. So, you know, I think as we look at adoption of NVMe, and these are numbers from IDC that we're looking at here, this is, you know, bringing all these different technology components together is why we saw kind of a slow adoption of NVMe. Of course, we had to get both single and dual channel out. Initial adoption was, you know, a single NVMe device in a single server instead of big storage systems. All these things had to come together to really see the market start to really grow. Now, today, all the technology is out there, and vendors are looking at how to put the different pieces together to bring this into the mainstream for all the market. And that's why we're seeing such a significant expectation on the growth of NVMe is the technology is coming together. It's reliable, it's available in the market, and the price has come down significantly where it's not just priced for very corner case workloads, that for high performance workloads in the mainstream, the pricing makes sense now as well. So let's talk about what made this difficult to develop. Why was the innovation curve for systems behind the actual devices coming out?
Sure, yeah, so the real hard part here is that you're changing the way you're interacting with storage. And so, like I said, it's pretty easy when you're dealing with a SAS or a SATA drive because it's just like it always was. And all the drivers and the operating system that dealt with SCSI and dealt with the drives going away just worked. And to make this huge shift to unlocking the potential of the flash, we had to deal with it as a PCIe device. And what's unnatural about that is this idea that a PCIe device could just disappear. Your computer doesn't expect your video card to just disappear, and when it does, it crashes. Like, it doesn't know what to do with that. And so, similarly, we had to create new standards, both at a hardware level and at a software level to deal with that. And so we're just starting to see this maturation of both the hardware coming together and the standards and the software being able to deal with that. And if you don't do this right, bad things can happen. And so if you don't build this right, you can end up where a drive failure, it looks like a PCIe device just disappeared and the OS can crash on that server. You can also have it so the drive LEDs don't work. You're not able to use the same standard SCSI methods to light a drive to tell you that this is a drive that has failed. You need to go replace it. And if you don't do this right, you could end up with weird procedures like the ability, your requirement to replace a drive is you have to shut down that server to unplug it and plug it in because the system hasn't been adapted to that dynamic movement.
So it sounds like you've been in the trenches a bit, working through some of this.
For sure.
As we've been developing this technology for Qumulo. So why now? Let's talk a little bit about where are we today?
Sure. So if we look at historically this shift from hard drive to flash, we're at a point where SAS and SATA was good enough. Like that was still like 100 times faster than hard drive, and everybody's like, holy cow, this is amazing. And we weren't really driving the need to have it go faster. We were already blown away by how fast it was. I mean, speak to anybody who's ever had a laptop that they got was based on flash versus their old one with a hard drive. They're like, I'm never going back again. Like,
Definitely.
This is the way to go, right? And that was even before we were using things like NVMe in a laptop. And so it was fast enough for a lot of applications. And for those places where we needed even more performance, you wanted to unlock the true potential. So like not uncommon to have like a very, in like a render or a video editor's workstation, I need to have super, super fast access for a temporary buffer. In those scenarios, what a lot of people did is they just put a PCIe card in. So you had a physical card, like a Fusion IO card, that you put in, and that was great, but the operating system, nobody had to do anything to deal with the fact that that could go away.
Right.
And so it wasn't like a traditional drive where you could pull things in and out in an enterprise system. And so that actually held us for a long time. But we've had some, and the technology, again, wasn't quite there yet either, and so we had to create new technologies. If we look at the physical form factor for a 2.5-inch NVMe SSD, it uses a new connector and a standard called U.2. And that just came out in 2015 was when the first drive started shipping. And so now that those are out and now that the OSs and software are being adapted to deal with the complexity of this removal process, we're now hit the sweet spot where the drives are shipping, they work, the technology works, the OSs can be adapted to handle that, and you're paying the same price for that flash. It seems kind of silly to not buy that in an NVMe connected system and instead of putting it versus putting it behind a bottleneck of a standard SAS or a SATA controller. And then the other thing is the market has changed. We want to unlock the potential of our data much more. We're at this inflection point now where data is more valuable than gold. Like it has a ton of value and people want to get more and more value out of that data. And that translates to I need my data to be accessible and I want to do interesting things with it. And then you combine with a lot of these workflows where they're trying to unlock the potential of their data, they're throwing machine learning at that, which requires very expensive hardware, GPUs, very expensive stuff. And if you buy and spend all that money on the compute and GPU side, and then you've got your storage is slow, well, that's literally burning money because those GPUs are crazy expensive, right? And so to unlock the full potential and to get to the value of your data faster, you need the data itself to be faster and served faster. And so we've hit this market change where people are ready now to go pay a little bit of a premium to go make everything go fast.
And take advantage of the investment they've made upstream on the compute side.
Exactly.
Makes sense. So, as we talk a little bit about price drops and we start to think about how Qumulo enables NVMe, I think maybe just take a second and talk about our business model and hardware.
Sure.
That, how do we get this innovation out to our customers quickly? Kind of how do we price it? Just a little bit about our mentality there.
Sure. So we have two methods for deploying our systems on premises for customers. We build our systems. We work directly with vendors to kind of shop the planet and find the right thing to combine the parts to build a great solution for customers. And then we have a software subscription on top of that. And then the other method is we work with partners like HP and Dell to create solutions where you can run our software on top of those systems. But if you look at our incentives are a subscription. So we're always working to make the system faster and faster. And we are not trying to push another new box on you. We just want to make sure that you're a happy customer and you're able to do your file workloads and you have success in what you're doing and hopefully expand as you need with your file workloads.
Great, awesome. So let's move on and talk a little bit about, on the Qumulo side, switching off of the hardware to the software. Mm-hmm. how we develop our file systems, and how we can release new technology quickly, kind of through our test cycle as well.
Sure. So we use Linux as an underlying OS, and it provides us a hardware abstraction layer. All of our system runs as a user space application, and we wrote all of our own protocol stacks, and we have a distributed data and operating system that runs on top of that. But the benefit we get with using Linux as this abstraction layer is it enables us to take new technologies like NVMe and new larger hard drives and bring them into our systems and quickly certify them. And so when we support a customer, we support a configuration, we are software, but we have all of that hardware in-house, because the reality is the hardware you run on top of, even when you're software defined, matters, and it's important that if a customer runs into an issue, we have that hardware in-house and we can replicate that issue. And so when it comes to adopting a newer version of the flash drive, we basically just buy a set of those drives, put them in a cluster, and run them through a certification cycle. So it is very easy for us to adapt new technologies, new capacity points, and bring them to market quickly. And so our core value here is to try to bring the technology faster to customers that's industry standard and get more value for our customers and get to better economics for our customers, whether that be a performance-based measurement or whether that be a capacity-based measurement for a customer.
Great. So thinking about getting the new hardware platforms out quickly, new developments and devices, storage technologies out there quickly, we do have to do a lot of work within our file system, though, to take advantage of it. Maybe let's just take the next couple of minutes and talk about performance optimizations. You know, we think about performance in terms of latency, throughput, IOPS, numbers of users. So let's talk about, you know, kind of how do we focus on the latency side first.
Sure. So on the latency side, we've done a couple things in just the last year to make all of this much faster. So we've done, we also have, we're talking about NVMe and All-NVMe flash systems today, but we also have a hybrid-based system that uses hard drives with some flash in front of it. And so we do a couple things. We actually look at the heat of the data. We look at the blocks that are active, and we proactively pull hot data into the flash tier when we're in the hybrid system. But on both flash and hybrid, we also do some intelligent look-aheads. So we look for patterns. We actually have some machine learning that we've done on this to understand what the access pattern looks like. So for example, if I have video.001 and I read that one and then I read .002, I'll start to see a pattern, and I will read proactively 003, 004, 005, and I will put it into RAM. So even on a hybrid or a flash system, I'm going to leverage the speed of RAM. And if you look at this chart, it shows that like the speed of RAM is like 0.2 milliseconds and SSD is about 1 millisecond. So even with an all-flash system, we can get performance boosts beyond just the fact that we're pulling off of an SSD. We can do these read-ahead patterns and get faster. And so the data that's being shown here is literally across our entire fleet, whether it's all-flash or whether it's a hybrid system. These are the latencies we see in responding to different requests from clients, and it's really a lot of cool software that we've done to make the system just much more responsive to the end user.
Awesome. So, yeah, I don't think most people think of NAS, scale-out NAS, as extremely low latency. You know, you often think of things as top-of-rack switches, running on InfiniBand, things like that. You know.
Right.
This is really incredibly low latency for a NAS system. Can you talk just a little bit about how networks have evolved on the Ethernet side to help enable this?
Yeah, absolutely. The beauty is that Ethernet's come a long way. So historically, when we built technologies like this, we'd have to use things like InfiniBand that were nice technologies, but they were not necessarily globally standardized within organizations, and Ethernet's come a long way. So now we have 100 gig networking, 25 gig networking are kind of the de facto standards now. 200 gigabit networking exists, but those things have all gotten much more responsive and lower latency in them. And so now we can build cluster technologies using standard Ethernet and have incredibly responsive systems. And I'm not having to buy a special switch for the back end or the front end. I've got the same type of infrastructure, and I'm not having to do special management saying, oh, no, I got to talk to the network guy to get approval to bring in the special kind of network technology.
Yeah, so going back to efficiencies, use your standard network that's already in place.
Yeah.
You don't have to have a specialized performance network and then gateways into your Ethernet network. So
super simple.
On this convergence of why now, the Ethernet technology, being as fast as it is, has helped to enable this entire story too, of getting into a single system, high performance, take advantage of these new technologies. Would you agree with that?
Yeah, yeah.
So let's talk about throughput. So this slide, oh, I'm sorry, this is still talking about latency, and I do want to talk about this for just a second. Mm-hmm. You mentioned earlier the custom-built NAS protocols and the importance of that. You know, so as we're talking about high-performance NAS, low-latency NAS, we've built our own SMB stack, for example. Why did we do that?
Because it's the only way you can really guarantee consistency. We hired people that worked at Microsoft and other places that were involved heavily in the protocol areas over at that company, as well as other expertise in the Seattle area. So we're based and started in Seattle, so we have a lot of good talent pool here to work from. And the reality is that you can't continually improve your NAS stack, your protocol stacks, without building it yourself. When you rely on other tools or open source things, I mean, those can work, but the reality is you can't really innovate forward. You can get basic functionality, but to make real progress forward, you have to basically look through a lot of open source code and try to get the open source community to change things. And I've worked in companies like that, and it's slow. If you want to innovate quickly, the right thing to do is just build it in-house and be protocol complete.
Gotcha. So our protocols are fast. They give the ability to share data across NFS, SMB.
Yeah.
So when you have lots and lots of users connecting these systems, we can deliver all the capabilities across any protocol stack as well.
And mixed protocols is super common now. You have a compute farm, usually Linux-based or Unix-based, that's rendering or computing or analyzing,
right,
running
sure.
machine learning, and then you have a human on the other end looking at those results, oftentimes with an SMB client, whether that's Mac or Windows. And so it's really a good portion of our customer base has a workflow where data is literally interacting over both SMB and NFS.
Right, yeah, and those shared protocols are something you don't find in a lot of the newer solutions coming out in the market.
Yeah, it's hard.
Yeah, it takes a lot of work.
It took 2 years for us to do that.
And then throughput, we certainly look at, if we're going to put super fast hardware underneath our file system, we need to make sure we aren't the bottleneck on the file system side too.
Yeah.
So talk a little bit about throughput improvements and how we think about that in our development cycle.
Yeah, so we're always working on performance, and we're always looking at, whenever we add functionality, we're looking at is there ways we can make this faster. And so we actually have a whole bunch of hardware in-house that runs a bunch of automated tests. So when a developer writes some code, it actually gets run against real hardware in the next day, and we get a result saying, hey, your change made something slow here. And so we're constantly trying to keep the bar at least at X, and then as we're trying to move the bar forward, we're continually doing development effort to improve performance across the fleet. And the good thing is that our software is the same software that runs on everything, whether that's running on the cloud, whether that's running on an all-NVMe system, or whether that's running on a hybrid system, it's the same software. So as we make these improvements, we see gains across all of those platforms where the software is being run.
Really great point. So as we tie things up, in summary, all of these different complexities have come together with Qumulo announcing this summer a platform called our P184, which is very high density, takes advantage of all these different innovations that we've been talking about running on 100 gig E. In the last quarter, about half of our bookings were running on this NVMe platform. So, it's available today. Customers are actually taking a look at, is this the time to make the switch with the economics and then the availability of the technology. So with Qumulo, we're the only vendor right now in the enterprise file space that's offering all-NVMe platform. We had a lead in the market because of the way we do innovation. And like Jason said, everything that we deliver, features, functionality, our software, the identical capabilities are built into this all-NVMe box that you would get if you bought a hybrid or if you ran in the cloud. So all the things Qumulo is known for, real-time analytics built into the file system, completely enterprise-proven, enterprise-tested from availability, directory services, permissions handling, everything that you need to install this, whether it's in your secure enterprise sites or if it's in research institutes, the solution is tested and ready to go. So we really appreciate you jumping on today. We would love to take any questions that might come in over chat, and after that, we'll tie things up. So let's take a look at the chat real quickly and see if we have any questions coming in. All right, I don't see any typed in questions. We'll stay on here for a few minutes. You're also more than welcome to reach out to Qumulo directly if you have any questions. Jason and I will be here for a few minutes, but thank you for joining today and have a great week.
Thank you.